Good morning, good afternoon, or good evening. Welcome from wherever you happen to be joining us today. My name is John Knepfle, and I'm a Principal Solutions Architect here at Elastic. The topic of my webinar is We're All Searching for Something, an Introduction to Elastic, and more specifically, an Introduction to Elastic on Azure. My goal today is to give you all an overview of what the Elastic Search Platform or the Elastic Stack is all about, and hopefully stir your imagination on how a powerful search solution can improve whatever you do, at work or at home. So let's jump right in. 3 plus 1. That's a pretty simple equation, but today I want to take a few minutes and show you that it adds up to a lot more than you might imagine. At Elastic, we believe that all of us are searching for something. Why we search remains constant. We're looking for insights, information, and answers. Why we search remains constant, but how and what we're searching is changing continuously, whether that's due to new types or sources of data, or simply due to the ever-increasing volume. The Elastic Stack is the foundation of everything we do. We allow you to bring all your data into one place where you can explore to get relevant answers at the speed of thought and at any scale. Speaking of scale, with the amount of data we deal with these days, sometimes you need help to know where to look and what to pay attention to. So we also make it easy for non-specialists to apply things like machine learning to help you understand where to look. The Elastic Stack has been engineered from the ground up to be the best foundation for building powerful search solutions. It's the plus one in that equation that I mentioned that powers and amplifies our solutions. Today, I'm going to show you 3 solutions that we've built on the Elastic Stack that will allow teams of all types to gain insights and understanding more efficiently than ever before. These solutions will empower all of your teams to achieve their goals. Whether you're a knowledge worker searching content for your next meeting or an application developer building a rich search experience for your customers, our enterprise search solution is designed to simplify your life by letting us do the heavy lifting to create a compelling, delightful search experience. Perhaps you're a site reliability engineer responsible for the health and performance of your business's mission-critical applications, living in a world of ever-increasing complexity. Inevitably, when things go wrong, and they certainly will, our observability solution is designed with the intent to drive mean time to resolution to 0. Or maybe you're a member of the information security team, trying to stay ahead of not only more and more data, but also increasingly sophisticated attackers. Our security solution will arm every analyst on your team to prevent, protect, and hunt for threats. Our goal for you is to eliminate all your blind spots. So let's take a look at how Gallivant, a fictional e-commerce business, is using Elastic solutions to empower their teams and ultimately to improve their entire business. By the way, Gallivant is cloud native and they've deployed their applications on Azure in multiple regions. Their architecture greatly benefits with Elastic's coexistence in those Azure regions. First, they're using Workplace Search, part of the enterprise search solution, to make it easy for anyone in the business to find information relevant to their team and their role. The app dev team has used App Search, which is also part of our enterprise search solution, to build a great search experience for their customers. Using the new Elastic Agent, Gallivant is able to collect logs and metrics from their servers and their users' laptops, while at the same time providing endpoint protection. They're also using Elastic APM for tracing and sending everything into another Elasticsearch cluster that's used by both the security team and the SRE team, since much of the data is relevant to both. Finally, Gallivant's sales and marketing teams are collecting business data for advanced analytics, as well as using Canvas to create eye-catching presentations with live data so that their executive team always has a real-time view of the business. Let's ride along and see how some of Gallivant's teams are using the Elasticsearch platform in action. Since Gallivant is an e-commerce company, we'll start with their customer-facing search experience. The application development team used Elastic App Search to provide their customers with the kind of search experience we've all come to expect when we're shopping online. As I start typing, you can see that we get completion and suggestions. And once I search for something, I have a selection of facets to quickly refine my search. These types of features can certainly be built from scratch by a team with experience in building search-based solutions. But with App Search, you get them out of the box, significantly reducing the time to delivery and even bringing the capability to deliver something like this within the reach of less experienced teams. Before we leave Gallivant's e-commerce site, let's take a quick look at one more thing the app dev team has delivered with Elastic App Search. Here's a chatbot they built to reduce the call volume into their customer support team. This makes it easy for a customer to get quick answers to basic questions like returning an item. So that's what the customer sees, but App Search provides rich features to the Gallivant sales team as well. Let's take a look at that next. Here's the App Search admin view. On the overview page, you can see the two search engines I just showed you, one for the actual e-commerce site and one for the Help Center chatbot. Let's take a closer look at the e-commerce engine. Here you can see some key metrics such as total queries, index documents, and clicks, as well as recent API events. For the Gallivant sales team, they'll be much more interested in the engine analytics that, again, they get out of the box with App Search. On the e-commerce analytics page, we see more KPIs like total queries, total clicks, and probably more importantly, total queries with no results. Obviously, on an e-commerce site, queries with no results isn't a good thing, so the sales team will want to address that. So how can the Gallivant sales team use these analytics? Let's use the queries without results as an example. It looks like customers are using the name Ultra Boost, which isn't returning any results. Ultra Boost is an Adidas shoe, but Gallivant doesn't carry that particular type. Well, rather than returning nothing, they can create a synonym set that will provide some results that might get their customers interested in an alternative. Let's go ahead and create a synonym set for Ultra Boost. This new synonym set takes effect immediately. There's no need for the sales team to reach out to the DevOps team for a code change and redeploy. When we search for Ultra Boost now, we get results that might keep the shopper interested. Next stop on our Gallivant tour will be with the SRE team. Recently, the support team has gotten a number of calls regarding issues with adding items to the shopping cart on Gallivant's e-commerce store. The DevOps team uses Elastic Synthetic Monitoring to keep an eye on performance of their site, and they've also seen an issue with the shopping cart service. Let's see how they use Elastic's observability solution to understand what's going on and hopefully resolve this issue quickly. This is the APM service map, and since I already have an idea that something is happening with the cart service, I could go directly to that and start my investigation right here. In the real world, that's probably what I'd do to resolve this as quickly as possible. But I want to give you a broader tour, so we'll come back to the cart service in a bit. The service map gives us a nice overview of all the services and how they interact with each other. We know there's some kind of a slowness when interacting with the Add to Cart button on the front end, so let's start with the front end service. Since we know the issue doesn't happen on page load, but rather when the user clicks the Add to Cart button, we'll take a closer look at the HTTP requests that are occurring. In this view, we can see the various requests being executed by the front end. The one that we're interested in is the post to the Add Cart API. Notice that Elastic APM shows you the overall impact of the various calls being made from the front end, and the API call to the Add Cart service is at the top, and that lines up with what we already know about this issue. Let's drill into the Add Cart service and take a closer look at the distributed trace. Since we know there's a latency problem with Add Cart, since the Add to Cart button occasionally runs really long, let's take a look at APM's latency distribution view. At the left, we see that normally this service completes in under a second or so, but here on the right, we see some outliers. This is a distributed trace for one of the normal calls, so let's compare that with one of the outliers. We see that this one definitely looks quite a bit different. Scrolling down, I see that these spans in red are calls to our Redis backend. And all the way at the bottom here, it looks like there's a sort on items in the shopping cart. And that seems to be taking a long time. The interesting question, though, is why does this only happen occasionally? Since we started at the front end, let's continue along that service invocation path and take a look at the next service in the transaction, the front end node service. This service is used to distribute calls to our other back-end services in our e-commerce site. I can see immediately that there are a couple of noticeable throughput spikes here. That could be related to the problem. When I move over to the transaction tab here, I see that there's a huge spike in HTTP 400 errors, and those seem to correlate with the latency spikes that I was just looking at. That's a bit suspicious, and usually as soon as I see something like that, in today's world, it makes me think of some type of attack. Might have to take a closer look at that, or maybe I'll mention it to Lisa on our security team just to see if she's aware of anything happening at her end. But before I do that, I want to continue looking at that service call sequence that I was looking at, and I want to take a closer look at the add cart call, which is the last stop in that sequence. Again, I'll focus on the slow transactions in the distribution view here. Here we'll take a look at our new correlations feature. This is an example of how we're applying machine learning, and we use it to look at factors that are correlated to these particular slow transactions. When I run this, I can see that there are a number of things correlated to this slow transaction. It looks like a specific Kubernetes pod and a specific container, and they are all related to service version 1.7. That might be interesting. It could mean that a specific pod or container is having problems, or that this particular version of the service is the issue. As someone on the Galvant DevOps team, I know we recently rolled out a new version of our cart service and that we're using it for some canary testing to try out a couple of new features. Let me take a look at that in a bit more detail and see if I can validate that hunch. Let me go back over to the cart service, and if I scroll to the bottom here, I'll see all the instances of this service that we currently have running. We have two instances, and obviously one of them has a much higher transaction latency than the other one. Taking a look at the service details, sure enough, I can see that this one with the issue is version 1.7, while if I take a look at the other one, version 1.6, that one appears to be okay. So at this point, I've probably validated my suspicion that our new version 1.7 is at fault here. All right, one more stop on the Galvant tour. Now we'll check in with the security team to see how they're using Elastic. Remember that when we were investigating that slow add to cart issue using observability, we noticed that odd burst of 400 series errors, and we were going to mention it to Lisa on the security team. This is the security overview page, and it does look like something has triggered some alerts. The first thing we'll do is to create a timeline for this investigation. Timelines make it easy to search and capture details as you investigate. A SOC analyst can also add notes to their investigation using Timeline. This is a great tool for the analysts on your team to collaborate on an investigation. Back to the alerts. It looks like several rules have fired. Speaking of rules, let's take one more quick detour over here to the rules page. And I just want to point out that you get almost 600 out-of-the-box rules developed by Elastic. Galvant is currently only using a small subset of Elastic rules, as well as one of their own custom rules. Let's take a look at the 3 alerts that were triggered. I'll filter for this first one. We provide you with details about the rule, such as who created it, the severity and risk score, for examples of false positives. And over here, you can see we show you that what data it's looking at and also details about its schedule. Let's clear that filter and take a look at the next alert that we've got. This one looks a little more interesting since it fired due to a 405 response, which indicates that the web application didn't process the request because the HTTP method is not allowed for that resource. Recall that in APM we saw a spike of 400 series errors, so this seems relevant. And this rule is indeed looking at that same APM trace data that we were looking at in the APM view. Let's jump back and take a look at that third rule that fired. This is a custom rule that Gallivant created, and it looks like one of the developer's payment details was used in the production environment, which should never happen. I suspect that Gallivant has seen this problem before, so they created a custom detection rule to look for exactly this scenario. You can add an investigation guide to the rule, so let's see what they've suggested. Gallivant is using Workplace Search, part of Elastic's enterprise search solution, to make it easy for the security team to search GitHub and a variety of other information sources. We can see that the connection was coming from this source IP address, which is not an internal address. Here's where we'll use that timeline. I can simply drag this IP address into the timeline. From the timeline, I can add notes, as I mentioned earlier, or I can look at details for this address, including checking it out in Talos or VirusTotal. Going back to the timeline, it's obvious that this IP address, which originated in China, has made hundreds of accesses. Let's close the timeline for now and go back to the alert details and explore a bit further. Let's open up the table view and look at the alert fields in detail. Scrolling down to the bottom, we see something worrying. It looks like that external IP address has actually been calling directly into our back-end services. Based on that suggestion in the investigation guide for this alert, let's grab this full URL and search for it in GitHub to see if we can figure out what credentials were leaked. This is Elastic Workplace Search. All of the teams at Gallivant use it to search across a wide variety of different content sources, including GitHub, Google Drive, Dropbox, and Salesforce, just to name a few. Obviously, not every team will need or want all of these sources. Which content sources, though, are available to each team, that can easily be configured by the Workplace Search administrator. Continue our investigation with Lisa now. Let's paste that entire URL that we copied earlier from the alert details in Elastic Security into the Workplace Search box here, and let's see what we find. The first hit is for an open GitHub issue that appears to contain that exact same URL. If I click on it, we get a nice overview card that might be all we need to see, but we can also click on the link at the bottom here, which takes us right to the issue in GitHub. Scrolling over a little bit in the code block, we see that one of our developers leaked some of our internal developer credentials. Well, that wraps up my little story about Gallivant and how they've gone all in with the Elasticsearch platform. We saw how the application development team created not only a rich search experience for their customers on their e-commerce site, but also a chatbot to allow their customers to get quick answers and, as a side effect, hopefully, offload some work from the busy Gallivant support team. After that, we joined the SRE team and saw how they were able to use Elastic Observability to quickly resolve an issue with a new version of a backend service that the development team introduced and was impacting customers. And finally, I showed you how the Gallivant SecOps team was able to investigate an issue which was caused by a developer leaking some internal developer credentials. The goal today was just to paint a picture with a really broad brush to give you some ideas of how you can use Elastic's 3 solutions, all built on the Elastic Stack. Thank you very much for your time today.